This lesson is on distance. So what is distance? Distance is another way to say the length of a segment. So the distance between 2 points is just the length of the segment created by those points. For vertical and horizontal segments, or segments that go straight up and down or straight across on the grid lines, we can simply count the boxes on a coordinate plane. But segments that are diagonal, we cannot count the boxes. So given any 2 points, we can use the distance formula to find the distance between these points. We can also use the Pythagorean theorem. The distance formula is derived from the Pythagorean theorem. So if I have 2 points, x1, y1, and x2, y2, we have the distance formula written here. This is again something that you are going to have to memorize. If we look on this diagram to the right, we can see a right triangle drawn in, where we have our distance of the segment, D, at an angle, and then we've sketched in a triangle by going straight across and straight up and down. And that would allow us to use the Pythagorean theorem. So if we do our first example here, find the distance between the points. What I'm going to do is I'm going to plot these points. 4, negative 4. So right 4, down 4, and negative 3, 3. Left 3, up 3. I want the distance, so I'm going to draw in that segment by connecting the 2 points. So in geometry, we're going to emphasize a lot more with the Pythagorean theorem than the distance formula. That's going to enable us to become more proficient with the Pythagorean theorem, and that's what we're going to use a lot this year. So to start, I'm going to draw my right triangle by connecting the points straight down on the coordinate plane and straight across. So the Pythagorean theorem is a squared plus b squared equals c squared. And c would be our distance. A and B would be the legs or the sides of that triangle. So I'm going to need to know the length of each of those sides, the blue and the green. Count the boxes. 1, 2, 3, 4, 5, 6, 7. So this blue side is 7, and the green side, 1, 2, 3, 4, 5, 6, 7. And then we talked about C as our distance, so I'll label the red side C. At this point, we just have a right triangle. So I'm going to go ahead and fill in the values into my Pythagorean theorem. A is 7 squared. Well, A squared is 7 squared. Plus B, which is 7 squared, equals C squared. So 7 squared is 49, plus 49 for the 7 squared again, equals C squared. Add the 49 plus 49, 98 equals C squared. Now, to undo the squared on the C, we need to square root both sides. So the square root of 98 equals C. We have to simplify or reduce that square root. So I'm going to come over here to the right, square root of 98. We need a perfect square number that goes into 98. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. The largest perfect square number that goes into 98 is 49. So instead of writing the square root of 98, we know we can write the square root of 49 times 2 and divide that into two radicals, the square root of 49 and the square root of 2. The square root of 49 is 7, and then we have the square root of 2. So this would equal our distance. It's a little bit more to take in mathematically, but it all comes back to using our Pythagorean theorem, drawing a right triangle and working down until we get to our C value. And then we're just reducing that. So we're going to do another one together, okay? Find the distance between the points. I'm going to start off by plotting these points. 5, 2, so right 2, up 2, and 2, 6. Right 2, up 6. I'm going to connect them so I can see the segment I'm trying to find the length of. So once again, instead of using like the distance formula and memorizing it, we're going to relate this all to the Pythagorean theorem in triangles. So the Pythagorean theorem, a squared plus b squared equals c squared. So I'll label my segment C, and I'm going to draw in the right triangle by drawing in straight down, count my boxes, and straight across. Count my boxes. So I'll draw this triangle off to the side so you can see it without the grid behind it. And now, all we need to do is plug these values into the Pythagorean theorem. So I'll use 4 for my a value, so 4 squared, and then 3 for my b value. 3 squared equals c squared. And remember, c is the length of my segment, or the distance between those points. Now we just need to simplify and solve. 4 squared is 16, plus 3 squared is 9, equals c squared. 16 plus 9 is 25, and we still have c squared on the right. So to undo that squared, I'm going to square root it. The square root of 25 is 5, and we have c. So our distance is 5 units. Or the length of the segment C would be 5 units long. Well, what if they don't give us a graph? You have a few options. You could go ahead and graph it yourself, or you can simply calculate the distance between the different x values and y values. We still use the Pythagorean theorem. A squared plus b squared equals c squared. But instead of counting the boxes and drawing the triangle in, we're just going to calculate how far between my x's and my y's. So from negative 2 to 4, I'm adding 6. And from negative 3 to 1, I add 4. Notice how I always went from the left point to the right point that's listed. The first listed point to the second listed point. Start with the first one and always go to the second one. So these values, 6 and 4, become our a and b values. 6 squared plus 4 squared equals c squared. We can do this without the graph. You are more than welcome to draw the graphs, okay? Do not feel like you cannot do that. I'm simply showing you a way to do it if you do not have that graph. 6 squared is 36, plus 4 squared is 16 equals c squared. 36 plus 16 is 52 equals c squared. And we know to undo the squared, we need to square root both sides. The square root of 52 equals c. That is your distance, the square root of 52. But we know that we need to reduce this. Everything needs to be in simplest form. So square root of 52, and we need a perfect square number that goes into 52. So I'll write the perfect square numbers down here on the side. And now we need to find the biggest one that goes into 52. In this case, it happens to be 4. So we can write the square root of 52 as the square root of 4 times 13. Split that into two separate radicals, square root of 4, square root of 13. And the square root of 4 is 2, and the 13 stays in the radical. So this would equal c, or in other words, our distance between the 2 points is 2 square root 13 units. Why don't you guys take a moment and see if you can work out example 4. Before you hit pause, remember how many units are between each set of x's and y's. Now go ahead and hit pause, see if you can work this out. Alright, welcome back. So I hinted and got you to start saying, find the difference between the x values and y values. So -4 to -1 is plus 3, and -2 to 4 is plus 6. The 3 and the 6 become my a and b values. So 3 squared plus 6 squared equals c squared. 3 squared is 9, and 6 squared is 36. That equals c squared. 9 plus 36 is 45. We know we need to square root both sides. So the square root of 45 equals c. You need to simplify and reduce the square root of 45. The square root of 45, my perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. For 45, the largest perfect square that goes into it is 9. So I'm going to rewrite the square root of 45 as the square root of 9 times 5. And we can divide that into the square root of 9 and the square root of 5. The square root of 9 is 3, and we cannot simplify the square root of 5. So 3 square root 5 equals c, or in other words, the distance of our segment, or the distance between the 2 points, equals 3 square root 5 units. So to wrap up our lesson, our points to remember for vertical and horizontal lines, lines that go straight up and down or straight across, we can count the boxes. If they do not go straight down or straight across, we want to draw the triangle and count those sides, and then use the Pythagorean theorem. If we cannot draw the triangle because we do not have a graph, okay, we'll add this in there. We're going to find the difference between the x values and the y values. And then we still use our Pythagorean theorem. And those are all the examples and things to remember for this distance video.